Good morning, students. Today in our class we are going to study uniform circular motion. First of all, we try to know what is meant by circular motion. Suppose if a body is going around a point, then we call that one as circular motion. Suppose if there is a buffalo which is tied to a peg with a rope, then it moves around that point of peg. Okay, that is its motion is around that point. Okay, whether it is maintaining constant distance or not, it is going around that one. Then we call that one as a loose circular motion. That is, the meaning is not there as it is a circle. Okay, generally we call the circle as if it is having constant distance from the point of observation to a fixed point. Okay, if the distance is very large, in that case we do not have clarity. But see, a circular motion is a motion where we are going to have a constant distance from the fixed point. We call this type of motion as circular motion. Okay, where the distance is supposed to remain constant. Then in this situation also, if a body is moving from one point to another point, if it moves from one point to another point with one velocity or one speed, from this point to another point with another speed, then in that case also the velocity is changing, the speed is changing. That is, from one point to another point it is having one speed, from that point to another point it is having some other speed. It is a situation where, suppose if we are having a fan, okay, if we switch on the fan, it slowly increases the speed and it maintains the same speed throughout its continued motion. Then if we switch off that one, then it slowly decreases its speed. That is, by switching on, it is slowly increasing, while it is switched off, it is slowly decreasing. That increase and decrease is also uniform. In between those 2 points, it is moving with same speed. If it moves with jerks, that is, if it does not maintain the same velocity, then we give that one to a repair. Okay, that is, we won't need that type of situation. That is, we consider the bodies where there is a uniform speed. That type of motion is called as uniform circular motion. Uniform circular motion. A circular motion where speed is constant is called as uniform circular motion, or where the magnitude of velocity is constant is called as uniform circular motion. Okay, we take that situation and we calculate the various things for that. That is, how the position is changing, how the velocity is changing, is there any acceleration on that body. We are going to consider these things. We take a circular motion, uniform circular motion like this. We call this one as eccentricity. Then at initial instant of time, we take the body or particle is at position P. We join this center with this point. We call this one as radius vector. Radius is the distance from this, that is circumference to center, is called as radius. Suppose after delta t time, if the particle is present here, call it as P1. The radius is changing R dash 1. Even though the magnitude of radius is constant, the direction is changing. That's why we call this one as radius vector. Okay, the change in this radius vector is this one. Is given by this. This is delta R. Delta R is the change. and triangle circumference at the center is delta theta. Okay, the radius is changing its direction continuously. That's right. If the radius is changing, velocity is also changing. The rate of change of this position is velocity. Then we are considering in our uniform circular motion the bodies which are moving with same speed. That is, the magnitude of velocity is constant. Here the velocity acts towards the tangent at this point. This is P1. Then at this point P1, it is, we call this one as B dash body. No doubt the magnitude is constant. Then for this situation we are going to calculate acceleration acting on this body. Okay. Then to calculate this acceleration we write the first magnitude of this acceleration. This is equal to d by dv dot by dt, or simply we write this one as limit delta as delta t tends to 0 delta mod delta v or by delta t. First to calculate magnitude. Okay. To calculate that magnitude we need this value. Okay. Then for that one we take this velocity here. We draw a parallel to this one v bar. Okay. Then after delta t time it is v dash bar. V dash bar. Then what is the change? This is the change. This is delta v. Then the change is taken through an angle delta theta. Okay, this is changing from its value from this position to this position through delta theta angle. Delta theta angle. Then we call this one as G, this point H. Okay. From this one we take the radius, modulus of radius. This is modulus of r. This is taken as r, and modulus of v dash, or first v or modulus of v dash, or we call this one as v. Okay, constant speed. This is v. Here speed is v. Now to calculate this value, okay, we go to these two triangles. It is from triangles CPP1 and CPP1 and GHI and GHI. From triangles CPP1 and GHI and GHI. Okay, this angle is same, this angle is same. This value is equal to this value. Here this value is equal to this value. These are similar triangles. Okay, side angle, side similarity. Side angle, side similarity. Okay, now by seeing these two triangles we can write delta v mod delta v divided by v mod delta v. This is equal to mod delta r divided by delta mod r. Okay, now this is nothing but delta v. This is v. This is equal to delta r divided by r. Okay, we go for substitution. Delta mod delta v is equal to v by r mod delta. Then substituting this value in this one, we can write mod a bar is equal to limit delta t tends to 0 delta t tends to 0. Instead of this one, we have to write this one. V by r delta r by delta r by delta t. Okay. But but this is delta r by delta t limit delta r by delta t as delta t tends to 0 is velocity. Velocity is defined as this. Velocity is defined as limit delta t tends to 0 delta r by delta t. Therefore, substituting in this value, mod a bar is equal to, okay, this remains constant first. V by r, we write this value as this is constant. V by r limit delta t tends to 0 delta r bar by delta t on delta r. Substituting this value here, we write instead of this one we keep v. Therefore, delta r is equal to v square by r. Then what about the direction? The direction is, see here, the change in direction is, it is towards the center. Is towards the center. That is, it is seeking the center. Okay, the change is seeking the center. That's why this acceleration is called as centripetal acceleration. Centripetal, that is, as it is seeking towards the center, it is called as centripetal acceleration. Okay, then writing that one, the centripetal acceleration is written as v square by r. Okay, towards the center. Okay, direction is towards center. That is, some acceleration is acting on the particle or body which is having uniform circular motion towards the center. Okay, we call that one as centripetal acceleration. As acceleration is acting, force is acceleration. It is also present. That is, the force acting on that one is called as centripetal force. That is, a force is acting towards the center for a body which is in uniform circular motion. No doubt, its value is also, or its magnitude is also constant. Only its direction changes. Okay, that is, the direction changes, but the magnitude remains constant. There is some constant force which is acting. That is, constant magnitude of force which is acting towards the center, or constant magnitude of acceleration towards the center for a body which is having uniform circular motion. Okay.